Ladies and gents, we are in week number 6 of online learning. How the time flies. Guys, we are done with algebra for now. Okay, we will come back to that later. We're going to deal with more difficult stuff. But for now, we're done, and we're moving into a little bit more easy stuff, and that's probability. Probability is a lovely, lovely topic, especially at this level. Okay, the questions are not too difficult. And the really nice thing is it's really common sense. Okay? Sometimes it doesn't even feel like maths. It's just kind of common sense. So we're going to start with a few introduction or reminding you a few things that we learned last year, basic like terms, and then we're going to look into solving some problems. So the probability scale, okay? When you want to say, what is probability? It's basically the likelihood, okay, for an event to take place. So what is the likelihood, what is the chance that we will be back here in school by the 1st of June? That's a question of probability. Now, the answer I can give is a number. Probability is a number, anywhere between 0 and 1, or 0 and 100%. Okay? Where 1 or 100%, if you want to work with percent, is certain. So that is definitely going to take place. So you might say the probability that we going to get back to school 1st of June is 100% or 1. That's certain. Or you can say probability is 0. Okay, no chance. Okay, so 0 means no chance. Okay? And then usually the case will be somewhere in between the two. Okay, we don't know. The answer is we don't know. So 0.5 or 50%, okay, 0.5 or 50% is basically even chance. It's an even chance. Okay? Either that way or the other, we really don't know. Okay? Sometime we might say there is a low chance, so a low probability. So there, a low probability will be around here, 0.1 or 0.2. There will be low probability. If on the other hand, as I would like to say, let's say it's high probability that we'll be back, maybe not, let's say 1st June, or maybe say by the end of June, then I would say a high probability that for the event to take place is going to be 0.8, 0.9, and maybe even 0.7. So that's high probability, high chance. Okay, so that's your probability scale. Pretty easy, isn't it? Now, another thing that we're going to talk about is what you call relative frequency. Another name for it is empirical probability. Okay? So what does that mean? Let's say, to give you an example, okay, let's say it rained, 5 days in the month of April. So we had 5 days of rain in the month of April. And then we want to say, let's say next April next year, I want to say what would be the probability that it will rain, basing on the information we had from this April. Okay, so let's say April had 30 days. I don't know if that's true. January, February, March, April. Yes, it does have 30 days. Okay, so 5 days of rain out of total of 30 days. What would be the probability or the empirical probability? Okay. Empirical means by experiment, okay, by using information from experiment. The probability will be, you would probably guess correctly, that it's 5 over 30. It's going to be the number of times the event took place, number of rains, in this case rainy days, 5 days, out of the total number of trials, out of total 30, so it will be 5 out of 30. And now when we write down a probability, we can use decimal numbers as here, or we can use it as a fraction. But if you write it as a fraction, absolutely right to write a fraction, but just don't leave it as 5 over 30, simplify it. So 5 over 30 is 1 over 6. Okay? So we've learned about probability scale and the relative frequency. Let's move now on to theoretical probability. Okay. So when we come to calculate theoretical probability, we calculate the chance for an event to take place, for something to take place, without doing the trying it again and again and again and doing an experiment. It's just by using common sense. Hang on, guys. Okay, sorry about that. So we're trying to calculate a probability just by using our common sense with actually trying it. That's amazing. We can actually do that. So let's say we have 7 black pens, 3 red pens, and 4 purple. What will be the probability of picking a red pen? Look at how I wrote it. So P stands for probability. That's probability. So we calculate the probability, usually we write in brackets of what event to take place. In this case, it's a red pen. Picking a red pen. So P of R. Okay? Now, if I have 3 red pens, all I got to do is divide the 3 by the total number of pens I have. How many pens do I have? 7 plus 3 is 10. 10 plus 4 is 14. So the probability is 3 over 14. Easy, isn't it? Probability of picking a purple pen, not a problem. That's 4 over 14. Because there's 4 purple pens. Picking up a black pen, 7 out of 14. Easy peasy. Let's move on to something a bit trickier. Okay, our next example, still very easy. We're rolling a dice now, okay? Now when I roll the dice, first thing, before I even look at the question, I need to think, what events can I have what possible, events that can take place? Well, either I get a 1, or 2, a 3, a 4, or 5, or a 6, a normal dice we're talking about, okay? Now, let's say the question is, what's the probability of getting an even number? Okay, that hash is a number, okay? Well, what numbers are even, okay? It will be 2, 4, and 6. So I've got 3 even numbers. So the probability will be 3 out of 6, which is half. Remembering we need to simplify. Next, what's the probability of getting a natural number? Now that's a very easy answer, but probably a lot of you forget what's a natural number. Well, a natural number is a number an integer, a whole number, which is bigger than 0. So 1, 2, 3, 4, 5, 6, 7, 8, all of these are natural numbers. Is there any no natural numbers? No, they're all natural numbers. So the probability that I'm going to get a natural number are 6 out of 6. They're all natural numbers. In other words, it's 1. 100%. We're going to get a natural number. Let's look at the next one. What's the probability that we're going to get a natural number which is larger than 6? 7, 8, or 9. Can I get them? Of course not. There is no possibility. So there's 0 events like that out of 6, and the probability is 0. No chance at all. Okay, we're going to move on to the next example, which is about cards. Okay, guys, when it comes to cards, that is where people struggle sometime, and the reason is not everyone knows what kind of cards we get. So we're talking about normal cards, okay? So I would really recommend you maybe playing a Remy game with your family, or any kind of card game, just so you kind of know for sure what the cards we've got there. So we have 4 suits. They're called 4 suits. We've got the clubs, the spades, these are the black one, and then you've got hearts and diamond, which are the red ones. In each one of these suits, we have 13 cards. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10. Plus 3, jack, queen, and king. So each suit is 13. 4 suits gives you a total of 52 cards. No jokers and all that stuff. Okay? Now let's solve these problems. So what's the probability to get a queen from any suit? Now how many queens we've got? 1 from each suit. So overall we have 4 queens. Okay? So the probability will be 4 out of 52 cards. Okay? Let me just pause that because a little bit of noise. Okay, sorry about that. Right, so the probability is 4 out of 52. Then they ask me, what's the probability of getting queen of hearts? So just the queen of hearts, not the queen diamonds and all that. So how many queens of hearts do I have in a pack of cards? Just 1. So the probability will be 1 out of 52. Okay, the 52, if you didn't know where it comes from, that's the total number of cards we've got in the pack. Then they're asking us, what's the probability of getting a spade or a club? Okay, any card, spade or club. So how many spades and clubs we have? We have 13 clubs, 13 spades, so we're going to have 26 spades or clubs out of 52. Okay? And remember, here we have to simplify. If you do that, you'll get half. But you could have answered that before, because card, either spade or club, well, that's half the pack, right? 2 suits out of 4, so the probability is half. And the last one, guys, that's a bit trickier. Probability of picking up a diamond card, but excluding king, jack, or queen. So let's think about it. How many diamond cards we've got? We've got 13. But now we're excluding, meaning we don't want to give jack, king, or queen. So we don't have 13 cards are we looking to pick up. We're only looking at 10 cards. And we divide that 10 by 52. The probability is 10 over 52. We can simplify it, 5 out of 26. And that's the answer. Okay? Easy, guys. You can do the exercise now. No problem. Easy lesson. Goodbye. See you tomorrow.